Okay, so your unit 3 of AEDC syllabus is on feedback amplifiers and oscillator circuits. Let us very quickly go through the contents of the unit. There are two subsections. The first one is feedback amplifiers. The contents are feedback concept, then the different feedback connection types, and then what is the effect of negative feedback on gain and the bandwidth. Okay, so these are the contents of subsection 1, which is on feedback amplifiers. Then coming to subsection 2, which is on oscillators. Okay, oscillators are based on positive feedback. So the contents are oscillator operation, FET based phase shift oscillators, Wien bridge oscillators, tuned oscillators. In the tuned oscillator circuits, we will be focusing on two very important type of oscillators. The first one being Colpitts and the second one being Hartley oscillator. Okay. Then we will also look at a very popular type of oscillator called as crystal oscillator. Okay, so these are briefly the contents of your unit 3. Okay, so let us now just focus on the concept of feedback. Okay, with respect to amplifiers, what do we mean by feedback? Okay, well, before that, let us just try to just generally try to understand what is feedback. Okay, say for example, let us consider the case of teaching itself. Okay, the teachers and the students. Teachers will be teaching you, and once the lecture completes, normally the teacher asks for feedback. Okay, the feedback, it could be positive or it could be negative, but taking the feedback from the students is extremely important, right? Why? Because feedback always helps for a teacher to improvise, to optimize his teaching skills. Okay, was there any lacunae, or was there any if there was any loophole involved, okay, or is there anything extra that a student needs. Okay, so all such things can be taken care only if a feedback is taken. Okay, what if there is no feedback being taken? Okay, if there is no feedback, then a teacher may feel that the teaching might be monotonous. Okay, if there is no proper two-way interaction, right? So applying the same thing in the case of amplifiers. Okay, we'll just assume through a very simple diagram here. Okay, so let's consider an amplifier. Okay, the sole purpose of the amplifier is to amplify the particular input signal. Okay, so let us assume that an input signal of such kind is being applied. Okay, an amplifier in the sense there will be a transistor always. Okay, so this amplifier amplifies the input signal so that we'll be getting amplified output. Okay, let us assume that it's a voltage amplifier so that there will be a amplified version of the input signal. Okay, all right. But the problem is, the input of the amplifier stage, okay, will not know anything about the output signal. Okay, nor will the input, okay, know about what has happened actually to the output signal. Okay, whether the amplifier has faithfully amplified the input signal or not. Okay, this information will be usually missing. Okay, so that is one criteria. Okay, the second aspect may be like, suppose if you want to control the gain. Okay, now say for example, if the gain is G1. Okay, now if you want to reduce the gain or if you want to increase the gain, okay, then what you will be doing? Okay, then the option is take a portion of output signal, feed it through a feedback network. Okay, So, and then the output of the feedback network is being fed to the input signal. Okay, so now in the first stage Vi was the actual input, but after taking a feedback loop, then at this particular node Vi will not be the actual input. Okay, it will be something else. Okay, that something else is Vi plus or minus the voltage appearing here, okay, at the feedback network. Okay, if you just consider it to be Vf, right? So the actual input which is being fed to the amplifier will be the mixture of the real input signal and the feedback signal. So in what way does this actually help? Okay, taking a feedback helps in two aspects. One is controlling the gain. Okay, the gain can be controlled. Now controlling could be either way. Okay, the gain can be increased and the gain can also be reduced. Okay, and the second most important aspect or the feature of feedback is you can control the gain and you can also control the stability of the overall amplifier circuit. Now these two parameters matter a lot, especially in the design of amplifiers. Okay, so I hope the concept of feedback is now clear. What is the need for feedback? Okay, feedback in simple words indicates taking a portion or entire of the output signal and then through a feedback network giving it back to the input signal, okay, and then finally to the amplifier is called as feedback. Okay. The main purpose of feedback is to control the gain and control the stability so that the overall performance of the particular amplifier is improved. Okay, so that's the main objective. All right, so moving next, let us try to understand, okay, the same thing, feedback concepts, with respect to a simple block diagram. Okay, so what all parameters are present? Okay, let us just try to look at these things. At the left hand side we have the original input signal Vs. Vs is the input signal. Then V0 is the output signal. The triangular shaped block indicates which is denoted by the symbol A. Okay, so this is the gain of the amplifier. Okay, which means this particular section is amplifier section. Okay, it usually consists of one of the biasing circuit. Okay, it could be a fixed bias, it could be a voltage divider bias, or it could be a self biasing circuit. Okay, and the active device may be a JFET, it may be a MOSFET, okay, or even it could be a BJT. But the point is the circuit should be an amplifier circuit with a gain A. Okay, all right. So then we also have a square square shaped block which is denoted by the symbol beta. Okay, so beta is the feedback factor, right? So this entire block is the feedback block, right? Now this parameter beta varies from 0 to 1. Okay, let me just indicate. Beta varies from 0 to 1. What does it signify? If beta is 0, that means out of the output signal, okay, nothing has been taken through the feedback network, okay, which means the feedback is 0. If beta is 1, that means the entire output signal, okay, the magnitude of the output signal completely has been taken through the feedback and then fed to the amplifier, right? So if the value of beta is in between 0 to 1, say for example 0.5, that means 50% of the output signal is being taken and then fed back. Okay, so I hope the concept of this parameter beta is clear now. All right, what about VF? Vf is the feedback voltage. It is the magnitude of the feedback voltage that is being taken through the feedback network and given. Okay. Now this circled thing is a mixer. Okay, it's a mixing stage. What does it do? Okay, this mixer stage adds up the input signal, okay, and the feedback voltage. Okay, both the things. Now the mixer, depending upon the polarity of the feedback voltage, okay, it may either add up the signals or it may subtract the signals. Okay. In this particular block diagram, this feedback voltage is indicated by a negative sign, okay, negative polarity. What does that mean? That means the phase of the input signal and the phase of the feedback voltage both are not the same. Okay, they are out of phase. Okay, to be precise, let me just draw it. If input signal is indicated like this, okay, and if the feedback voltage is indicated like this, okay, wherein there is exactly 180-degree phase shift, right? Okay, so what will be the VI? See, VI is the net input signal which is actually being fed to the amplifier, and this is VS plus or minus VF. Okay, hope you can understand. So this plus means both of them are in phase, VS and VF are in phase. Minus means VS and VF are out of phase. Okay. Now can we call this in phase and out of phase by some proper technical words? Yes. Okay. How? So there are two types of feedback. Okay, the first one being negative feedback and the second one is positive feedback. So the characteristic feature of negative feedback is that the feedback signal is out of phase with respect to the input signal. Okay, just the point which I had mentioned. Okay, right? So which means the feedback signal VF and input signal VS, both of them are out of phase. Okay, both of them are out of phase. Similarly, if the feedback is positive, then VF and VS, okay, are in phase. In phase. Okay, so that's the basic difference in feedback. Although this is the basic difference, but the resulting output is completely different. Okay, if the feedback is negative, then the output will be completely different. Its properties, its characteristics are different. If the feedback is positive, then the resultant output will also be completely different. Okay, so let us just go into some more details of negative feedback. Negative feedback results in decreased voltage gain, for which a number of circuit features are improved. Okay, now this point is quite natural because I just mentioned that negative feedback means the feedback voltage VF and the input signal VS are out of phase. Out of phase. Okay, so which means say for example, if VS is 5 volts and VF is 3 volts, okay, just for example, then the actual VI, which is VS minus of VF, will be 2 volts. Okay, this is during the first phase. Okay, that means negative feedback results in decreased voltage gain. Okay, so if the input after feedback has reduced, then it is quite obvious that the gain, okay, we usually represent the gain by symbol A, which is V naught by Vi. Okay, so the gain also reduces accordingly. Now what are the other features? Negative feedback improves or it increases the input impedance. Okay, so it has higher input impedance. Then better stabilized voltage gain, which is also a important feature. Then negative feedback results in improved frequency response. Okay, we'll be talking about this voltage gain, stability and the frequency response again at a later stage. So further, negative feedback lowers the output impedance. Negative feedback reduces the noise, very very important, and it improvises the linearity. Okay, more linear operation. Right, so these are all the added effects or the advantages of negative feedback. So for this purpose, most of the amplifiers use negative feedback. What about positive feedback? Don't we have any circuits that use positive feedback? No, we have circuits. Okay, positive feedback drives a circuit into oscillations, which is not possible with a negative feedback. Only positive feedback can drive the circuit into oscillation. So if there are oscillations, then the main application will be in oscillators. Okay, so all the oscillators employ positive feedback. Okay, so moving further, we have a comparative chart, okay, which tries to compare positive feedback and the negative feedback in a really exhaustive manner. Okay, almost all the points are being included here. So let us very quickly try to go through the points. Positive feedback is also called as regenerative feedback. Okay, this regenerative in the sense the effect of the feedback goes on continuously increasing. Okay, the amplitude goes on increasing in the case of positive feedback. Negative feedback, degenerative, right, which means the strength of the output signal goes on reducing as the number of feedback stages increase. Okay, so a negative feedback, degenerative, and positive feedback, regenerative. Okay, then relation between input and the output signal. We had just discussed that positive feedback, both input and output are in phase. Negative feedback, and they are out of phase. Overall gain. Okay, when we say overall gain, it is including feedback. Okay, in the sense what is the gain with feedback and without feedback. So what happens in the case of positive feedback? Greater than the gain of the system where feedback is not present. Okay, that means if you give a feedback, then the gain increases with respect to the initial gain when the feedback was not present. Similarly, negative feedback, the gain will be smaller if you give the feedback. Okay, what about effective input? Effective input is the sum of the applied input and the feedback signal. Okay, and why it is sum here? I just mentioned because both of them are in phase. So two signals which are in phase can be added, so it is a sum. However, negative feedback, both of them are out of phase, so obviously it should be a difference, right? So it's a difference of applied input and the feedback signal. Next, transfer function of a system with respect to feedback. Okay, in your textbook the symbols are different. Okay, they are being used as a upon 1 minus beta into a, where a represents gain without feedback and beta is the feedback factor. Similarly, here it is a upon 1 plus beta into a. Okay, and we usually denote it as AF, which means gain with feedback, right? So similarly, gain with feedback is expressed like this for a negative feedback. Then coming to stability, the most important point. Positive feedback circuits are less stable. Okay, please concentrate on this point. They are less stable, whereas negative feedback are comparatively more stable. Okay, so in terms of stability, which feedback should we go for? We should go for negative feedback always if we want a higher stabilized circuit. Okay, however, if you want a better gain, then go for a positive feedback. Similarly, phase shift. For a positive feedback, the phase shift is either 0 or 360. Negative feedback, 180 degrees. Then feedback is taken from non-inverting terminal of a op-amp. Okay, since we are not discussing about operational amplifiers here, we will ignore this point as of now. Okay, but in your next semester, when you take up the course on linear integrated circuits, definitely this point will be taken again. Okay, so that you can understand this particular point in a much better way. What do you mean by non-inverting terminal and the inverting terminal of an op-amp? Okay, op-amp stands for operational amplifier. Then sensitivity, positive feedback low, negative feedback high. Usage, positive feedback are used in oscillators, negative feedback are used in amplifier circuits. Okay, so that was a pretty good exhaustive comparative analysis of positive feedback and negative feedback, right? Okay, so there was one point to be discussed here regarding stability and the gain. Okay, stability and gain. Normally, stability and gain of a particular circuit are of a particular amplifier circuit are inversely proportional to each other, right? That means if we want to improvise the stability of a particular circuit, then its gain automatically reduces. If we want to reduce the stability of a particular circuit, then its gain automatically increases. Okay, now the point is, should we go for a higher stable amplifier circuit or should we prefer a higher gain based amplifier circuit? As a thumb rule, okay, stability is given more preference when compared to the gain. Okay, if your amplifier circuit has normal gain, it is more than sufficient. But the most important point is its stability. It should be pretty stable. Its operating point should not fluctuate with respect to temperature variations or with respect to other changes, right? Okay, only then we can say that this particular amplifier is more reliable, right? You know, otherwise, if the gain is pretty huge, very high, and suddenly if the amplifier circuit breaks down, its stability collapses, then there is no use of a higher gain, right? Okay, so a circuit engineer, a circuit designer should always be very cautious in designing the amplifiers. Okay, he should take care of stability as well as the gain parameters. Okay, so for that, positive, negative feedback, both the things have to be considered. Okay, fine. All right. So the next topic will be the different feedback connection types. Okay, so there are 4 different types: 2 with respect to voltage and 2 with respect to current. Similarly, 2 with respect to series connections and 2 with respect to parallel connections. Okay, so we'll be discussing these things in our next class. Okay, so all right. So if there are any doubts regarding positive feedback, negative feedback, you can ask me. Okay, and regarding these points, we will be discussing these things in a lot more detail in our next classes. Okay, all right. So any doubts, students, you can ask so that I can try to answer. Okay, so I think we'll stop here and then continue in our next class.